Hi, and welcome to the next lesson, which is on position vectors. Okay, so let's do a little warm-up first so we don't forget any of the previously learned material. Find the vector of magnitude root 7 in the direction of 4i plus 6j minus root 11k. So remember what you need to do. Work out first of all, what is the magnitude of this vector? And I think it was find the unit vector, sorry, I was going to say find the unit vector. So what is the magnitude of this vector? Use the Pythagoras in 3D formula. So square root of 4 squared plus 6 squared plus negative root 11 squared. So 4 squared plus 6 squared is 16 plus 13. Negative root 11 squared is negative root 11 times negative root 11, which is positive 11. And the square root of all of that, 16 plus 36 plus 11 is 63. What's the square number that goes into 63? That's right, it's 9. So 9 times 7 is 63, so that simplifies to 3 root 7. So what we then need to do is, so you need to divide each of these numbers, 4, 6, negative root 11, by 3. Yes, and why? And that, I see. So I didn't say find the unit vector because a unit vector has a magnitude of 1. So in this instead it said find a vector with magnitude root 7. If it said find the unit vector with direction of this, it wants one with magnitude of 1. But this one wants the magnitude to change from 3 root 7 to root 7. So obviously to change the magnitude from 3 root 7 to root 7, you need to divide this by 3. So divide this by 3 turns it into root 7, because 3 root 7 over 3 cancels down to root 7. So we need to divide each of these by 3. So you need to divide everything by 3, downsize by a factor of 3, so that the new vector has a magnitude of 7. So the new vector would be 4 over 3i plus 6 over 3j. 6 over 3j simplifies to 2j, because 6 over 3 is 2, minus root 11 over 3k. And there you go. So if you pop this into the Pythagoras theorem in 3D, then you would get a magnitude of 7. If you want, let's prove it. This squared is 16 over 9. This squared is 4. So you've got 16 over 9 plus 4 minus root 11 over 3 squared becomes 11 over 9. So 16 over 9 minus 11 over 9, that part would simplify to 5/9. Plus 4, and so on. Oh, wait, do you see what I did wrong? That's right, this squared is actually plus 11 over 9, not minus 11 over 9. So that squared is 16 over 9, plus this squared is 4, plus this squared is 11 over 9. So 16 over 9 plus 11 over 9, what does that equal? That's right, that equals 27 over 9, which is 3. And then 3 plus 4 is 7. Don't forget the whole thing was square rooted, so that's how you get root 7. So just proving that this new vector has a magnitude of 7, root 7, sorry, which is what the question asked for. If it asked for the unit vector, you'd want it to have a magnitude of 1, in which case you would have divided each of these numbers by 3 root 7. And I don't know why this happens, but it just does. Okay, here we go. Okay, here's another warm-up. Let's warm up again. Given that vector PQ, so meaning the vector that joins point P to Q, is in 3 dimensions, so it's minus 3, 4, 2, so it's x coordinate, y coordinate, z, and so that's minus 3i plus 4j plus 2k. And vector RP is 1, 3, 5, so I plus 3j minus 5k, find QR. How on earth would you do that? So notice that QR connects Q and R. So we've got P to Q and then R to P. So that's kind of interesting. QR, why would QR be QP plus PR? Let's see. So basically, notice if you start at QP and then you take off from P and go to R, overall it's the same as going from Q to R. So notice that QP is the reverse of PQ, and PR is the reverse of RP. So alternatively, you could have worked out RQ and then find the negative of that, but that's also another method. So feel free to do that if you want and see if you get the same answer. So QR, because you notice QR, it's like starting at Q going to P, and then from P going on to R. So that's why you can come up with a plan like this. QP is like the negative of PQ, so 3, negative 4, 2. And PR is the negative of RP, so negative 1, negative 3, 5. So we've got here, this one becomes the negative of this, plus this one, which is the negative of this. So 3 plus negative 1 is 2, minus 4 plus negative 3, minus 7, minus 2 plus 5 is 3. So that's how you get 2, negative 7, and 3 as your answer. And they just are fine with a column vector, so they didn't ask you to turn it into IJK form. So if it was IJK form, you would go 2i minus 7j plus 3k. But this is a nice column vector, so just leave it like that. Okay, moving on to what on earth are position vectors. A position vector is one which begins at the origin, which we tend to call O. So we tend to note the origin as point O, and extends to another point, like it could be A or B. So position vector, by definition, starts at the origin, basically. So if it extends to point P, then it's position vector x, y, z, blah, 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 and so on. So it would be a column vector x, y, z. So position vector basically starts at the origin and extends to another point. Sometimes OA, you might have seen, or OB, or something like that. So basically it just means that it starts at the origin. Origin has a 3D coordinate 0, 0, 0. So something like in 2D, so we've got a two-dimensional kind of thing going on here, two-dimensional plane, and extends to another, for example. So we've got x and y axis. So notice we went across 2 and we went up 3. So OA is a position vector because it begins at the origin, basically. That's what we mean by position vector. Position vector is not a free vector as it's fixed to the origin. That's what makes it a position vector, as I keep going on about. It starts at O and ends at another point, for example, A. It's fixed at the origin. So we can also write position vectors as lowercase letters in bold. For example, we could say OP, because notice there's an O here, meaning it's meant to be the origin. OP in this case would be bold B. So in your handout it's probably got bold B, but if you were writing this on exam, you'd write, sorry, P, not B. You'd be writing P and you'd put in a little line underneath it, rather than trying to write it in bold. So OP equals P, yep, and there's another one there. OQ is another example of a position vector because it starts at O. OQ is Q in this case, and so on. Therefore, vector PQ, out of interest, could be written as, I'm just recording a video.
Hello, people of the world.
Hi, Sophie. You mean? So vector PQ can be written as, PQ is the same as going from PO to OQ. So going from P to Q is the same as doing PO to OQ, which in this case would be negative P plus Q. So negative P plus Q. If you were handwriting this, you would have a little line underneath those. So PQ, you could write negative P plus Q. You might find in some answers they quite like to rewrite it as Q minus P. It's the same thing, just looks nicer. So that's interesting. Okay, continuing on, same page. The points A, B, and C have position vectors. This is a try for yourself, so feel free to pause and try it yourself, and then see if you get the same answer as me. So points A, B, and C have position vectors A, B, and C. Position vectors because they start at point O. Point P is the midpoint of AB, so right smack bang in the middle. And point Q is the midpoint of BC, so smack bang in the middle of these two. Find the position vectors of P and Q, according to A and B, basically, and C. You can use A, B, or C. So here we go, da 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 da. So what's a pathway to get from A to P? That's what we've got to think about. What's a pathway to get from, sorry, O to P, not A to P? The position vectors of PQ. So basically I want to work out what's OP for this answer, and for this one, what's OQ is what you want to work out for that one. So let's try that. So position vector of P, think of it as it's like OA plus AP. So OA plus AP is easy enough, but how can you write that in terms of little a and little b and little c? So when you think of it, it's OA, which we know is A, plus half AB, because P is the midpoint. So OA plus plus AP is the same as OA plus half of AB, which could be written as A comes from the OA, plus a half, AB equals B minus A. How come they've got AB equals B minus A? Try to think of that. That's right, it would be because another way of rewriting AB is to go this way and this way. So if you're writing AB in this case, it would be minus A plus B. So see, going from A to B, minus A plus B. And AP is half of that. So it's like saying half of minus A plus B. Notice this is a bit of, B minus A is a bit more elegant than writing minus A plus B. So A plus half of this vector, and this vector is minus A plus B. So then you could expand all that. So a half times B, a half times minus A, gives you A plus a half B minus a half A when you expand this. So basically we've expanded this. I'm just pointing out that this thing here is AB. So A plus a half, sorry, A minus a half A is a half A, and a half B is just still a half B. So you end up with a half A plus a half B. Fabulous. So that's vector OP. So that's position vector OP. So we've got OP is, nice way, you could write it like this. This is fine. Another nice way you could also write it is 1/2 brackets A plus B. So remember, you're handwriting this, so you don't have the opportunity to put it in bold like we do on the computer. So on this one, you should put a little line under the A, a little line under the B, and a little tiny line under the A to indicate that they're vectors, rather than put them in bold, because it's like, you know, the examiner might not realize you put it in bold. So you're meant to put a little line under here, a little line under here, and a little line under here, and a little line under here. Make sure you do that because you're handwriting your answers. Now we're going to do position vector of Q. Position vector of Q is very similar. It's like going from OB to BQ. And OB to BQ is the same as OB plus half BC. So OB plus BQ is the same as OP plus half BC. Make sure you put the little arrows above as well. And equals B plus BC. Another way of writing BC is minus B plus C. Because see, BC, it's minus B plus C. So BQ must be half minus B plus C. So B plus a half, rather than minus B plus C, you can write C minus B. So see, this one here is BC, and it's halved. So expand this now, a half C minus a half B. B plus minus a half B is half B, and then you've got plus a half C. Nice elegant way to write this is position vector OQ. It's position vector because it starts at the origin, and it's fixed, equals a half brackets B plus C. It's a nice elegant way. Please, because you're handwriting these now, if you haven't already, put a little line under here, a little line here, tiny line here, a little line here, a little line here, a little line here, and a little line here. Super important. Otherwise it's not a vector, it's just looks like a variable instead. So go a few more examples. The point O is the center of the regular hexagon. So it's a regular hexagon, meaning that all 6 sides are the same length. Given that OA equals A, so position vector OA is A, and AB equals B, find OB. So OB, when you think of it, OB is the resultant vector of doing OA plus AB, isn't it? So good to write out your little plan. Make sure you put your little vector signs. You don't need to do double bits on the arrow. You can just do like this, like that when you're handwriting it. That's okay. So OB equals OA plus AB, which is A plus B. So again, because you've handwritten this, can you please put a little line there, a little dash under there, and a little dash under there. It's like a little tiny underline, just under the letter. That indicates that it's a vector. So we've done that one. So BD, where's BD? BD is this green one here, green one going in this direction. So we kind of know that those two are parallel. So going down here, and we kind of know that these two are parallel as well. What pathway did I take? I did that BD equals BC plus CD. So BC is like negative A, isn't it? Because you're doing the reverse. It's like negative AO, sorry, negative OA. So negative A for this one, and here we're doing the reverse of this one. So it's like, if this one is A plus B, then going down this way must be minus A minus B. So just pointing out that that's the same as it equals AO, because it's parallel to that one, and BO, because see, like this one's like AO, this one's parallel to BO. Because negative OA and so on, all that rubbish. And so, like, because notice it's this one's negative A, and this one's minus A minus B, or you could write minus A plus B in brackets, which is, or you can go straight to minus A minus B. So you get minus 2A minus B. Now, can you go back and just put a little line here, a little line under there, a little line under there, a little line under the A, not under the 2, but under the A and under the B, to indicate they're the vectors. And then we've got to do CF. Oh, sorry, CF was back here. So CF, where on earth is CF? CF is this blue one going across here. So let's see, you could do all sorts of things. You can go across here, across here, across here, go up here, down there, across there. What could you do? Let's see, we're probably going to go like here. Let's see what I end up doing. So CF equals, oh, I went this way, CD plus DE plus EF. CD we've got down here. CD we know is minus A minus B, because it's a negative of this, plus DE. DE is just the reverse of this one, so DE is minus B. And then EF is parallel to A, so it's plus A. So we've got this one here is minus A minus B. And then this one here is minus B, and this one here is A. Add them all together. That's like minus A minus B. So minus A plus A cancels out. Minus B is minus 2B. So that does make sense to going backwards by B. So the answer does make sense. Can you please now go back and put a little line here, a line there, a little line under here, a line there, a line there, and a line there, and a line there. Make sure the lines don't go under the numbers or the negatives or the pluses, just directly under the letter. This tells you that FC is parallel to AB. Yeah, FC is parallel to AB because they're scalar multiples of each other. Isn't that interesting? Okay, so OABC is a parallelogram. Here's our parallelogram. With OA equals A, they've got that there. OB equals B. Oops, OB is here, equals B. The point P lies on AB, extended such that AB equals to the ratio of A to B to P is 2 to 1. And the point Q lies on CB such that the ratio of C to Q to B equals 1 to 3. What on earth does that mean? Express each of these vectors in terms of A or B. Okay, so the point P lies on the line AB. Where's the line AB? AB, sorry, here. AB is here. The point P lies on the line AB, so like somewhere on here, such that A to B, the line A to B to B to P is in the ratio of 2 to 1. That's pretty amazing. So basically, the line AB is twice as long as the line BP. So P must be somewhere in the middle there, roughly. And the point Q lies on line CB. Here's line CB. So here's Q. I'm looking at AB to B to P. Ah, sorry, yeah. So P's out here somewhere, sorry. So P's out here somewhere. So because A to B is twice as long as B to P. So P's about here, sorry. Because it's A to B and then B to P. I was thinking A to P. And then it says point P on AB extended, so that's why I've extended the line. So point P's out here somewhere. And then point Q lies on CB, and it's drawn on CB, such that C to Q, the ratio of C to Q to B, is 1 to 3. So in total there's 4 parts, 1/4 here, 3/4 there. So that's why if this is, notice this is A, so this whole one must be A. So this must be 1/4 A, and this one must be 3/4 A in total. So that can be helpful to draw out. Express each of these vectors in terms of A and B. So AB, It's like going negative A plus B. So negative A plus B, or B minus A. Negative A plus B is the same thing as B minus A. We want to do AP. AP is all the way out here. So we know that AB is B minus A. So therefore, if this one is like 2 and this length here is 1, in total that must be like 3 parts. So it's like 3 over 2. So A all the way out to P must be 1.5 times AB, which is like 1.5 is like 3 over 2 AB. So 3 over 2 AB, we know AB is B minus A, so it's 3 over 2 brackets B minus A. You can extend it if you want, extended it. It's fine if you don't want to. OP, exhausting. OP is all the way out here. So we know that one's B. OP is all the way out here. So it's like doing A plus AP. So it's like doing O to A plus A to P. And we already know that A to P is this one here. O to A is A. So it's like saying A plus AP. Expand this, you get 3 over 2B minus 3 over 2A. A minus 3 over 2A is minus a half A. Because A is like 2 over 2A minus 3 over 2A is negative a half A plus 3 over 2B is left there. And then OQ is here. So we know that AOC is parallel to AB's. So on. Oh, alternatively, the way they did it, they did OB minus 3/4 A, because we know that's 3/4 A going this way, so minus 3/4 A. That makes more sense. That's easy because it's already labelled. OB is B minus 3/4 A. That's done already. And then, what's the last one? Oh, B. Hence show that vector QP, QP is out here, so Q out to P, so vector QP. Hence show that QP is a quarter A minus a half B. So they've told us the answer, it's just to show that question. So QP, got to do out to here. So QP, let's see, what could we do? We could do this, this, and this. We can do all sorts of things. So the way they've chosen to do it, QP, they've started with OP. So they're starting with OP. OP is this one here that we found already, because we've already found OP down here. OP and minus OQ. So OP minus OQ. So we're going O to P minus O to Q would be the same as this, because it's in a way it's more like going minus this. No, hang on, we were doing P to Q. QP, because we're doing because notice, or in a way I would think of it more so as this. Minus OQ plus OP, if that makes more sense. So QP is like going the reverse of this, so QO plus OP is the same as doing Q to P. So we know this one already, QO, because it's a minus of OQ, so that's why we've got minus of that, and then plus OP we've got from over here. Add them together, because notice it's minus B plus 3/4 A. Minus a half A plus 3/4 A is a half A, no sorry, a quarter A. How's that? Let's see. Minus a half A plus 3/4, oh yeah, because adding 3, you've got to add a half to get it up to 0, and then there's an extra quarter, so a quarter A plus a half B. 3 over 2B minus 2 over 2B is 1 over 2B. So now can you please go back and put a little line here, line here, line here, little line here, 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 and here, 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 here. Make sure it just goes under that exact letter. And probably here and here as well. Very important. So it's pretty tiring, I know. We've still got some more to go though. because we just can't get enough of this. The position vectors, feel free to try for yourself or just pause and check the answers if you want. Position vectors of the point A, B, and C are 2i minus 1j plus k. And then, so that's this one, going from O out to here. Then going from here to here is this vector here. And from here to here is this position vector here, respectively. Show that A, B, and C are collinear. Collinear means you're in the same line. So, yeah, okay. Let A equal that, B equal that, and C equal that. That's done. So that's what these things have been labeled. Okay, so AB equals B minus A or minus A plus B. Doesn't matter how you look at it. So minus A it would be -3, -2, plus 1. Wait. Oh, sorry, no. Minus A is this one. Yeah, sorry. Minus A, oh, they're doing it this way, B minus A. So put B here. B comes from 3, 2, 1. Minus 1, sorry. Minus A is 2, -1, 1. So you know what that is. AB, so when you add these, subtract these, 3 minus 2, 2 minus minus 1, minus 1 minus 1, you get this. So we've worked out what AB is. So work out what the line of AB is. We're basically going to try to prove that this one and this one are scalar multiples of each other. BC is like going minus B plus C, same thing as plus C minus B. So put in plus C here, 6, 11 minus 7, minus B. B is 3, 2 minus 1. 6 minus 3, 11 minus 2, minus 7 minus minus 1 is minus 7 plus 1, which is minus 6. So I've just got to prove that this one is a scalar multiple of that. So you can prove that this one is a scalar multiple by the fact that you've got 3 times that equals that. So then notice that thing is that thing. So if you times this one by 3, you get that. So that's what we've kind of shown here. So BC, vector BC is the same as 3AB. You could also say BC is a multiple of AB, scalar multiple, which means that BC and AB are parallel. And one thing they're not just parallel, to prove that they're collinear. Collinear means that they're in the same line. That it's not just this one's here and this one's down here, they're in the same line. So you prove they're scalar multiples, so first of all prove they're parallel. Then to prove they're collinear, mention that AB and BC have a common point, which is point B. Therefore they're collinear. Yay. One more to go. Here we go. Feel free again to pause and try it yourself. Diagram shows a trapezoid, trapezium, because it's got one pair quadrilateral with one pair of parallel sides. X and Y are the midpoints. So X is midpoint of OB, Y is a midpoint of AC. OA equals A, I've got that there, OC equals C, and CB equals a half A. So always good to double check that it's been drawn on a diagram, just in case they didn't put it on there. Then you can put it on there. Next one, find each of the following vectors in terms of A and C, simplifying your answers where possible. OB, that's a nice one, OB, nice easy pathway, go with the ones that are labelled already. You would go OC plus CB. OC plus CB is C plus a half A. So C plus a half A, or a half A plus C, doesn't matter. Can you please go and put a little line under here, a line under here, a line under here, and a line under here. Then OX. OX is halfway. It's basically half of this. So what would happen if you halved this? So if you halved that one there, half C plus half A, or half A plus half C halved, half C plus a quarter A. So a quarter A plus a half C plus a quarter A. Can you put little lines here, 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 here? AO, where's A? AO, AO. AO is kind of like, let's see, kind of like doing minus A. So that's a dead easy one. You might have been thinking, oh, what's some different pathways I can take? Sometimes it could be right in front of you when you miss it. OA is already A, so AO is just minus A. Put a little line under here and a little line under here, please. AC, junk. AC is minus A plus C, which they might write as C minus A plus C. C minus A, doesn't matter. Just put a little line under here, a line under here, a line under here, and a line under here. Make sure the line doesn't go on the negative or the positive sign. Same picture still. Let's continue on. Oh, AY. So AY is, Y is the midpoint. Even though it's not drawn to scale, they said in the question back here, Y is the midpoint of OB. So the midpoint, so you've got to halve this basically. So half negative A plus C is negative a half A plus a half C. Put a little line under here, a line under here, line under here, and a line under here, please. It's okay if you wrote a half C minus a half A, same thing. OY, 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 OY. So you could do OA plus AY, because OA is just A, and then plus AY. So OA plus AY equals A minus a half A, because this is OA, and then minus a half A plus a half C is AY. Then combine your like terms. A minus a half A is a half A, plus a half C. Put a little line, 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 please. XY. Goodness gracious me, what's the best way to do it? Different ways you could do it. I chose to go zhunk, zhunk, zhunk. So I did XO plus OA plus AY. XO is, from the previous slide, just a reverse of OX. So that's why we've got minus a quarter A minus a half C. And minus a quarter A minus a half C plus OA, which is just A, plus AY. And AY is a half A, sorry, negative a half A plus a half C. Combine your like terms, you've got negative a quarter A plus A is 3/4 A. 3/4 A minus a half A is a quarter A. Now we've got minus a half C plus a half C, that's gone. That's how we end up with a quarter A. So what did you deduce about XY and OA? So XY is a quarter A, OA is A. So we deduce that they're parallel. XY and OA are parallel because they're scalar multiples of each other. XY is a quarter of OA, and they are parallel because they are scalar multiples of each other. Oh, thank goodness, it's over. That was pretty tough. So well done.